My name is Tom Harris, and this is Exploratory Journeys. My guest this week is Dr. Howard Hayden, Professor of Physics Emeritus of the University of Connecticut. A Colorado native, Dr. Hayden earned Bachelor, Master's, and Ph.D. degrees in physics from the University of Denver. Following this, Howard went to the University of Connecticut, where he spent 32 years teaching and doing research. His research background is in accelerator-based atomic and molecular collisions. And he tells me that that's not the kind of high-energy accelerators use in particle research. Dr. Hayden is editor of The Energy Advocate, a monthly newsletter promoting energy and technology, which has been running for 26 years. He is the author of, among other publications, The Solar Fraud, Why Solar Energy Won't Run the World, which I really recommend to people, by the way. It's on my shelf, that's for sure. A primary on CO2 and climate, a primer on renewable energy, and my favorite, which I love, I've read many times and I use often in my work, is Bass-Ackwards, How Climate Alarmists Confuse Cause with Effect. We will include links to all of these books under the podcast of this program. So, welcome to the show, Professor Hayden.
Well, I'm glad to be here. Nice
That's
to talk
great.
to you, Tom.
That's great. Well, many people think that energy from the sun and the wind are free. Now, what's the simplest response you can give to such, somewhat misguided people?
Well, sure. The energy is free. Finding a way to make it useful is not free.
Uh-huh.
Well, I guess you can go out and get a suntan, but that's using solar energy, and that's free.
Yeah.
But other things, no.
Mm-hmm. And it's funny because they call them green energy, but in the case of wind turbines, they're industrial wind turbines. So they're the opposite of, low technology. I mean, they're high technology, and they obviously produce a lot of pollution as well, when you're making them, that is. So would you call them green technology?
I kind of use the adjective green to refer to things that I see that fit that color. I invented a term called chromoergic psychosis, which is the delusion that energy has a color, usually green.
Oh, right.
In any case, we should talk a little bit about these big wind turbines. Imagine something like a 1.5 megawatt wind turbine standing up there, maybe 100 meters tall or something like that. The wind is pushing up there on the hub, and under conditions where you have a pretty decent wind and you're producing full power, the leverage that exerts on the ground is more or less equivalent to the weight of a school bus out on the end of a plank the length of a football field.
Oh, wow.
So you see that there has to be one heck of a lot of structural base to hold that thing in place so it doesn't blow over.
Mm-hmm.
The second thing to recognize is that the power from a wind turbine varies very dramatically with the speed of the wind. For example, you get about, I'll use miles per hour. You people up there in Canada are still familiar with it. If the wind is blowing 20 miles an hour, you get about 8 times as much power as you get when it blows 10 miles an hour.
Oh, okay.
And so what that means is that when the wind is varying a little bit, as it always does, the power that the wind farm puts on the line goes up and down and up and down and up and down, and it has to be compensated by something in order to maintain a fairly steady voltage on the grid.
Mm-hmm.
Another aspect that people don't really come to grips with is that let's suppose you take a big windmill compared to a smaller windmill.
Okay.
And we'll take one that has double the diameter. If you double the diameter, that particular wind turbine can produce 4 times as much power.
Okay.
On the other hand, you have a bunch of these laid out in a grid, and you have to place them. They're usually placed something like 10 diameters apart. Well, if you double the diameter, you have to double the distance to the nearest windmill, and that's in both directions.
Mm-hmm.
So you get 4 times the power in 4 times the land area, which means that the power per unit land area is pretty much constant.
Oh, okay. And what would that be about per?
Well, it turns out to be about 12.5 kilometers per hectare.
Or kilowatts, you mean?
Yeah.
Kilowatt.
12.5 kilowatts per hectare.
Oh, okay.
So long and short of it is, well, let's see, how big is Ottawa?
Well, I don't know how many square miles, but I'll look it up while you're talking.
No, I'm sorry. What I'm interested in is the population.
Oh, okay. It's 1 million.
It's 1 million. Okay, so you'd need something like 1.3 billion watts to handle them.
Oh, okay.
And the long and short of it is you'd need something like 600 square kilometers of wind turbines in order to produce that power. 600,
okay. And I'm just looking up to see how big Ottawa is. Of course, it contains a lot of farmland that is fairly nearby. And area, 2.8 million square... Million? Yeah, it must be million square kilometers. No, Federal City is 2.8. Well, Joseph, what is the area of the whole city?
I don't know. I'll look it up.
Okay, Joseph's going to look it up. Because, one of the things that I figure, Howard, is they want to put up 710 industrial wind-scale turbines, typically, as you say, 100 meters high. And they can't be too close to dwellings. They can't be too close to each other. So I wonder if it even fits geometrically.
Well, I don't even know, but you got the numbers, and your readers, your listeners have the numbers, and they can look it up too. Mm-hmm. But there's an aspect of this thing that perhaps the people there are not considering, and that is that. Well, now I want to describe a phenomenon to you, and so you'll understand what happens.
Okay.
As the blades turn around, when a blade comes directly in front of the tower, it produces a little thump.
Okay.
Okay, and so you get this thump, 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 and some of the newer wind turbines are designed so that they feather that particular blade so it doesn't happen as much. But it puts a kind of a nasty vibration into the ground.
Oh, yeah.
And this vibration is felt by people who are living close to, meaning sort of within a kilometer or so of the wind turbines. Mm-hmm. And I haven't experienced it myself because I'm a long way from a wind turbine. But anyway, people do complain about it, and they complain a lot. Mm-hmm. In other words, they just want to abandon the whole farm because they can't stand it. They can't sleep at night.
Yeah.
And then another problem that you have is shadow flicker.
Right.
And that is that you say you got a window that's facing the sun. Then if there's a wind turbine between you and the sun, and this includes any part of the blade, then all of a sudden it just goes dark for a second, and then it comes bright, and it goes dark for a little bit and comes bright again. Mm-hmm. And this has turned out to be very irritating. And I should think that up at 45 degrees north, this would be particularly bad because that shadow extends a long way.
Oh, yeah.
Especially in the wintertime, it would extend a long way. Yeah.
Yeah. So people who live near them, I'll bet they're not terribly healthy people.
Oh, well, there have been, quite a number of cases where people just really, really felt bad. They weren't getting enough sleep and all kinds of stuff. And I'm not an MD, and I have no direct contact with that. But from what I read, that can be a kind of an awful situation.
Mm-hmm. Well, I understand that in many countries they're now talking about a 2-kilometer setback to homes. But in Ottawa and Ontario, I believe it's only about a half a kilometer, 550 meters, something like that. So it sounds like within a half a kilometer or just a little more, you're not going to be very happy living near one.
Well, I think that's very likely the case.
Mm-hmm.
And the main question is, why bother?
Mm-hmm.
Why not get energy from nukes? To give you an idea, one nuke can sit easily within a square kilometer and supply all the electricity you need around the clock.
Yeah. And Howard, I was actually, some time ago, I was learning that the amount of high-level waste that you would produce in your entire life, if you got all your electricity from nuclear, would be about the size of a golf ball. So think of all the pollution that's produced with all the materials they make to make wind turbines, thousands of them to equate to one simple nuclear station. I just wanted to read you a quote from Councillor Scott Moffat, who's chair of the Standing Committee on Environmental Protection, Water and Waste Management for the City of Ottawa. He said, concerning the 710 industrial turbines and 36 square kilometers of solar panels, he said, the actions we need to take to protect the environment are good for municipal taxpayers because they will help us save money through energy efficiency and climate resiliency. Will wind and solar power actually save money and give them climate resiliency?
Well, it hasn't really happened that way. The places that have gone very big on solar and wind in Europe have all had rather escalating energy prices.
Mm-hmm.
Because it's the point is that solar and wind are unreliable. And I bet you if you asked your neighbor if it gets dark at night, he'd probably say yes.
Yeah. But what about batteries? I mean, people talk, we can just store the energy for a city of 1 million. Are batteries realistic?
No. In fact, there's not a battery installation in the world that's capable of holding. Well, in fact, I would put it this way: you take all the battery installations that have ever been made, they would be inadequate to hold the electricity for, say, one whole day's worth of energy usage in Ottawa.
Wow, yeah. And think of all that lithium mining that they're going to have to engage in. And that's, of course, not environmentally friendly, is it?
Well, not really. Mm-hmm. Not really. But lithium, by the way, is found, it has pretty much the same chemistry as sodium. So you find it where you find sodium, and you find sodium where you find sodium chloride, in other words, salt.
Oh, okay.
So you look for lithium in salt flats, mm-hmm. but it's a very, very small fraction of the amount of sodium that's there. So you have to do a whole lot of processing
mm-hmm.
To get the lithium out. Lithium, well, we're using lithium batteries all over the place, but there have been many cases where they have just plain caught fire for some reason or another.
Oh, wow.
And it's not a fire you can just put out with water.
Okay. Is that why these wind turbine fires at the top of the wind turbine, they'll burn for long periods of time? Partly, I guess, is because it's hard to get to the fire.
Well, no, they wouldn't have the batteries up there. What burns up there is a couple of things. One of them is the oil that's in the transmissions.
Right.
And sometimes if you look at those fires, and there have been a few that are posted on the net, you see some stuff